Namaste and welcome to this video. I am Turakhia, the facilitator for Maths subject. In this video, we are going to study about the statistics. It is one of the branches of mathematics that has applications in various different fields. Now there are 5 topics under this unit statistics, and we have divided this 5 points in 2 different videos. In the first video, you will learn the frequency distribution of raw or ungrouped data. Then you will learn the frequency distribution of grouped data. And at last, you will learn how to construct a frequency polygon of the given data. The other 2 points are discussed in the next video, whose link is given in the description below. Begin with our first point, frequency distribution of the ungrouped or raw data. First of all, data is a set of given facts in numerical figures. If you take any set of numbers related to some particular survey, that forms your data. There are basically 2 types of data. First is primary data, that is collected by investigator himself or herself with a definite plan. And the second one is the secondary data, that is the data collected by someone other than the investigator. Means secondary data is reuse of the data which is collected or taken by an investigator. Now, what is raw or ungrouped data and how to find its frequency distribution? Let us see with the help of an example. The sale of shoes of various sizes at a shop on a particular day is given below. So there are different numbers given: 7, 8, 5, 4, 9, 8, 5. All these are sizes of shoes that are sold on a particular day at a shop. So we are directly noting down the size of the shoes which is sold. So such type of information collected or such type of data collected is called raw data. Now, how to make a frequency distribution of this raw or ungrouped data? So we make a frequency table. The frequency table has 3 columns. The first column is of sizes. In this case, we are dealing with the sizes of shoes. So we list down all the sizes that are available in the data one time. So starting from the smallest size 4 to the largest size 9 in this given data, we list them in the first column. The second column is tally marks, which is basically counting of each size. And the third column is frequency, which is the counting, the number of times a particular size or a particular number occurred in the data. So let us begin with the tally marks. The first number is 7, so you put a mark or a tally mark or a count against the number 7 in the size. The next number is 8, so you put a count against the number 8. Number is 5, So you put a count against the number 5. This putting of counts or a vertical line are basically tally marks. So this we keep on doing for each and every number available in the data. Now here we see the number 8 is coming for the 5th time. Now just for the sake of conveniency in counting these vertical lines or tally marks, we make a group of 5 tally marks. So whenever a particular number is coming for the 5th time, we mark it as a cross line above the 4 previous lines. So this represent a group of 5 times the number 8. Then we do it for the remaining number, our tally marks in the table. Now once we are done with all the numbers with their tally marks, we count the tally marks for each of the given sizes. So the size 4 has tally mark 1. That means the shoes of size 4 is only one which is being sold on that particular day. In the same way, the tally marks for size 5 are 3. That indicates that there were 3 pairs of shoes sold on the particular day of size 5. And similarly we do for all the available sizes or the given numbers. And then at last we add up all the frequencies. So we count the tally marks of each value and take the total of all frequencies. Now getting the total of all frequency confirms that we have counted all the numbers that are available to us in the data. Now this table helps in interpreting the data more conveniently rather than just looking at the raw data. The tabular form says that for a particular size, say for example size 7, we can directly see the table and say from the frequency column that there were 4 pairs of shoes of size 7 sold on that day. Similarly, we can also figure out from the table that size 8 was the highest sold for that particular day. After the ungrouped data or the raw data, we will now learn the frequency distribution of grouped data. As the name suggests, we make the groups in the given data. Now these groups are of various sizes that depends on the data available to us. So we make first groups of suitable size. Each group is called class interval. So actually we are defining the limits for every group. Every class interval is bounded by two numbers that are called class limits. The lower number, or the number written on the left side of class interval, is called lower limit, and the greater number of the group, or the number written on the right side of the class interval, is called upper limit. Now there are two types of grouped frequency distribution. The first one is exclusive form and the second one is inclusive form. Exclusive form of grouped frequency distribution is also called as continuous interval form, whereas inclusive form is also called as discontinuous interval form. Now this naming of the two types reveals most of the things about these two types. In exclusive form means something is excluded, and here the upper limit of each class interval is excluded while making the frequency distribution. On the other hand, lower limit is included for every class interval. One example for class interval of exclusive form looks like this: 0 to 10, 10 to 20, 20 to 30, and so on. Talking about inclusive form, as the name says, both the upper and the lower limits are included for every class interval. For example, 0 to 10, 11 to 20, 21 to 30, and so on. Now you can clearly see from the example of exclusive form is forming a continuous class intervals. Like the first class interval is 0 to 10 ending at 10 and the second class interval begins from the number 10 itself. On the contrary, if you see the inclusive form, in the example the first class interval is 0 to 10 and the next class interval starts from the number after 10, that is 11 to 20. So this is the basic difference between two types of group frequency distribution, and so are their names. Let us take one example to understand and to know how to prepare a frequency distribution for both discontinuous as well as continuous interval form. So we are given with the different set of numbers. So we make both the types of frequency distribution for the same data. One is exclusive form, another is inclusive form, or you can say continuous class interval form or discontinuous class interval form. The tables for both these types looks same. The basic difference is in the class interval. For exclusive form or the continuous form, the class intervals are in a continuity, like 1 to 10, 10 to 20, 20 to 30, 30 to 40. Now we have decided this class size, or as we have seen in the first slide of this grouped frequency distribution, we have to make groups depending upon the data. So here we have made groups of size 10 because our data ranges from 3 to 38. The minimum number available to us is 3 and the highest number is 38. So we have made 4 groups of size 10 each. Now in inclusive form or discontinuous class interval form, you can see the class intervals are 1 to 10, then 11 to 20. Then next class interval begins from 21 to 30 and then 31 to 40. Now we start with the telemarks. We take one by one every number available in the data. We have to keep in mind exclusive form, we are counting only the lower limit, or we are including the lower limit only. We are not including upper limit in every class intervals. Whereas in inclusive form we are including both upper and lower limit. Now the first number 3 belongs to the same class in both the types, interval 1 to 10. So we put one telemark against the class interval 1 to 10. Then 25 belongs to the class interval 20 to 30 in exclusive form and 21 to 30 in inclusive form. So we put one telemarks against their respective class intervals. The same thing we do for 38, 23, you have to identify a particular number belongs to which of our class intervals, and you have to put a telemarks against that class interval for that number. The next number is 13. 13 for exclusive form belongs to 10 to 20 class interval, and for inclusive form belongs to 11 to 20 class. Now comes the number 10. Now you have to be very particular while making the telemarks for the numbers that are the limits of class intervals. Now 10, as you can see in the exclusive form, is appearing in two different class intervals, that is 1 to 10 and 10 to 20. Now as we have seen the difference between exclusive form and inclusive form, in exclusive form we are not counting, or we are excluding the upper limits. So for class interval 1 to 10, upper limit 10 is excluded. For class interval 10 to 20, the upper limit 20 is excluded. That means 10 is included in the second class interval of exclusive form, that is 10 to 20. Whereas inclusive form, you don't have to worry about such numbers, as we are including both the limits, upper and lower limits, and 10 is appearing only one time in the class intervals. For number 10, you see for exclusive form 10 belongs to the class interval 10 to 20, where 10 is the lower limit, and in inclusive form it belongs to the class interval 1 to 10. You have to be careful while marking the telemarks for such numbers which are the limits of the class intervals. It is 30 to 40 class interval in exclusive form and 31 to 40 in inclusive form. Now for exclusive form, it belongs to the class interval 20 to 30, because 20 is the lower limit. for the class interval 20 to 30. Whereas 20 is appearing only one time in the class intervals of inclusive form. So it belongs to the class interval 11 to 20. In the same way, now again this is fifth time telemarks coming for the class intervals. So we group them by a cross line. Now number 30. I am sure you must have guessed where the 30 telemark must be done for exclusive form as well as for inclusive form. Yes, exclusive form belongs to the class interval 30 to 34, 30 to 40, and for inclusive form it belongs to the class interval 21 to 30. This telemarking for all the remaining numbers, that is 28, and now once we are done with the telemarks of all the numbers, then we count the frequency for every. So we find the frequency for each class interval and then we add up all the frequencies. So for exclusive form, the frequencies are 1, 5, 5 and 4, and the total is 15. And for the inclusive form, frequencies are 2, 5, 5 and 3, that is again total 15. So this is how we do telemarks, or we prepare a frequency distribution for continuous class interval form as well as discontinuous class interval form. Now there must be a question in your mind that how can we convert or a discontinuous interval form into a continuous interval form? Yes, there is a way, there is a method to convert discontinuous class interval form to the continuous form in the same example. First of all, we find the difference between upper limit of any one class and the lower limit of its consecutive class. So if we take upper limit of first class interval, that is 10, and the lower limit of its consecutive class, that is 11, the difference is 1. You can take any two consecutive class intervals, the upper limit and the lower limit. You will find that here in this example that difference is 1. Then divide this difference by 2 to get the adjustment factor. Now this factor is required for this conversion of inclusive form to exclusive form. So we divide the difference 11 minus 10 by 2, that is 0.5. So our adjustment factor in this example is 0.5. Then we subtract this adjustment factor from each of the lower limit of the given class intervals, and we add the same adjustment factors to each of the upper limits of all the class intervals. So for the first class interval, lower limit is 1, and if we subtract 0.5 from 1, we get 0.5, and the upper limit is 10. So adding the adjustment factor 0.5 to 10, we get 10.5. So the first class interval that is formed is 0.5, to 10.5. And the same thing we do for remaining class intervals to get the continuous class interval form from discontinuous interval form. After learning the frequency distribution of grouped and ungrouped data, let us learn how to construct frequency polygon. Now, by the time you must be knowing the word frequency, it is number of times a particular variable appearing in the data, and the polygon is also a familiar word. It is a closed figure made up of line segments only. So, we have to construct a polygon using frequencies. Now, there are few basic steps to be followed for construction of frequency polygon. The first step is to find the class mark of each class interval. Now, the class marks are nothing but the midpoints of every class intervals. Suppose the class interval is 0 to 10, then the midpoint is 5. That can also be obtained as the average of upper limit and lower limit. Now, after finding the class marks for every class interval, we take this class marks on x axis with appropriate scale. Now, taking of scale depends on the data that is available to us. Then on y axis we take the frequencies again using the appropriate scale depending upon what frequencies are available in the data. We take an appropriate scale for that. Now, we have to plot the points like we plot the points on coordinate axis. The same way we have to plot the points. Now, here our x coordinate is class marks and the y coordinate is their corresponding frequencies. So, we have to take the points as class marks and frequencies. Now, the important thing is we have to take two more classes that are called imaginary classes, which are not actually given in the data, and we have to take the frequencies of this imaginary classes as 0. Now, these two classes are not together, but one is taken in the beginning, that is before the first given class interval, and the second one is taken at the last, that is after the last given class interval. Now, the reason for taking imaginary classes is that it will help to complete the polygon that we will see in the example coming up next. And then once we have plotted all the points, we join all the points in sequence to complete the polygon. Now, here we are joining the points as a line segments by taking scale and pencil. It is not a just freehand joining of points. Now, let us take one example to see how we construct the frequency polygon. Suppose the question is, the following table shows the marks obtained by the student of a class in an examination, and we have to draw a frequency polygon for the given data. So, as you see, the class intervals are 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. So, first step in construction of frequency polygon is to find the class marks. So, the class marks are the midpoints of every class interval. So, the midpoint of the first class interval 0 to 10 is 5. You can get this by adding the upper limit and the lower limit 0 and 10, and then divide the answer by 2. So, 0 plus 10, that is 10, divided by 2, that is 5. So the average of upper class limit and the lower class limit will give you the class mark. Similarly, we find the class marks for all the given class intervals. Now using this class marks and the frequencies, that is number of students, we plot the graph. The first thing on graph we will label x-axis, y-axis and the point origin. Then depending upon what class marks we have in the data, we take those class marks on x-axis using a suitable scale. Here we have taken the scale as 1 unit equals to 5 marks. In the same way, depending upon what frequencies are given in the data, we take that on y-axis using a suitable scale. Here on y-axis also the scale taken is 1 unit equals to 5 students. Now there were two imaginary classes that we need to take for frequency polygon. The first one was before the first given class. Here the first given class interval is 0 to 10. So a class interval before this would be -10 to 0. And the class mark or the midpoint of -10 and 0 is -5. So we take that class mark on x-axis, and the another imaginary class interval was at the end, that is 50 to 60 in this example, and the class mark for 50 to 60 is 55. So we take that class mark also on x-axis. Now for all the class marks along with the class marks of imaginary class intervals, we have to plot the corresponding frequency against each class mark. So for the first class mark, that is 5, the frequency number of students given is 15. So we plot the first point as 5 and 15. Similarly, second point would be for the class mark 15, the frequency is 32. In the same way, we plot for all the given class marks. Now once these points are plotted, we have taken frequencies 0 for the class marks of imaginary class intervals. So that points will remain on x-axis only. Now we have to join these points using line segments one by one. Now as you can see, if you join only the class marks and the frequencies of the given data, your figure is not a closed figure. Therefore we cannot say this as a polygon. So to make it a polygon, a closed figure, we had taken those two imaginary class intervals, and that by joining with their 0 frequencies, we would see that our polygon is completed along with the x-axis. So this is how a frequency polygon is constructed for the given data. Now in some of the data, it is not necessary that the class marks will always start, or class intervals will always start from 0. In this example, you can see the marks are starting from 20. Class intervals are 20 to 24, 24 to 28 and so on. The class intervals are at the gap of 4, and so the class marks are. Now if you see on the x-axis, starting from the origin 0 and also taking imaginary class before the given data, the first number or the first class mark that is required for our frequency polygon is 18, as it is already joined, but After 18, if you see the scale, every 2 units marks are going up by 4. But this is not the case with the first 2 centimeters, first 2 units. From 0 it is directly going to 18 and then it is increasing by 4. So, in such case, when we do not have the initial data from 0, we use a mark like this on x axis. Now, this mark is called jagged line or kink. Now, this represents that there is no data between 0 to 18. Now, the same thing can also be marked on y axis if we do not have the initial frequencies. I hope this frequency polygon is clearly understood, along with the frequency distribution of grouped and ungrouped data. We will see 2 more topics on this unit, statistics, in the next upcoming video. Thank you for being in the session. Hope you have enjoyed the learning.